All right, folks, thank you. I think we can get going. Really been wonderful session so far, and this is an opportunity for the project members and board members to introduce themselves and to take questions about what they're doing and how you can participate in different ways. So members who are here include myself, Hervé, Marcel, Jen. Members who are absent for various reasons are Alex, Bob, Nikhil. We meet a couple of times a week to talk about issues related to the whole ecosystem, our build system, and so forth. And all are very energetic contributors to the project, maintaining infrastructure, core bioconductor packages, often falling on the shoulders of Hervé and Marcel. And Lori, managing the release process, promoting and developing software for interoperability between platforms, and working on new technologies, WebR, Kubernetes, LLMs, and then wonderful things like Build a BioC workshop and the workshop itself. Very good. Any comments or questions for the core? The Technical Advisory Board is a different sort of animal. It meets every month for a 1-hour meeting. And you can imagine that the technical material that could be discussed at these meetings can be very extensive. We have folks from many different institutions, pretty diverse group, and the calls are all have an agenda stated in advance with open contributions from the tab to enter agenda items, and then each set of minutes is published on the Bioconductor website, thanks to work of Charlotte. Lori has already mentioned various ways of getting involved with the Technical Advisory Board. You can be nominated, you can join a working group or suggest and lead a new working group, and if you succeed in getting a working group together, your group will get a seat at the table of every monthly meeting of the TAB to help advise and maybe provide direction to the project. And so joining the TAB through self-nomination or nomination by others, and there will be announcements very shortly. What the TAB has been working on includes discussion of how to deal with the cloud, governance, infrastructure, the build system, spatial data imaging, interacting with Python, using GPUs, the workshop platform, and the idea of the monograph, which has always been an important component for the past few years. ASCA, ASTA, and new contributions of book length. And so there are meeting minutes available as noted here. Working groups that we have at the moment include, and these are working groups, I think, for both the TAB and the CAB. Conference planning is certainly CAB, as is code of conduct. Cloud methods, developer training, education, governance, mass spec, multilingual, documentation, privacy, publication, class selection, spatial and multiomics. And a number of these need input. For example, the industry working group, I think, has sort of decayed, but folks who are here from industry are welcome to help us understand the relationship to industry and improve it. And the annual call for new TAB members is open, and so the application form is available if you use that QR code. Questions for the TAB? All right.
Okay, I'll just go through a couple of slides on CAB. I'm here representing the Community Advisory Board. There's a number of people online virtually, Laurie, Janani, and some others. So CAB briefly was set up in 2020 by Aideen Culhan and Matt Ritchie to support the global community as Bioconductor had grown a lot. So these are the members of the current CAB. So they represent a diverse group from across the world. And same slide as what Vince showed, there's a number of working groups that CAB supports. CAB members lead some of these groups and participate in others. The last bullet point there is saying your idea here, because we welcome people proposing new groups on topics or focus areas of interest. And just briefly, some example projects that we, the CAB, have been involved with. One was the redesign of the Bioconductor website. So we had a preview of that at BioC 2023 last year here. And we got, for the design, we got a lot of input from the community, and that shows the comparison of the old and new website. So thanks to people who gave that input. And we also have a focus on training and supporting groups, training, teaching bioconductor skills and methods around the world. So we've got a Bioconductor Carpentries program, had a workshop before this conference. We've got more instructors beginning, and we encourage anyone to get involved with the Education and Teaching Committee. That's one of these working groups. And just want to highlight, we've also got a new activity on translation framework that's been developed by Kozo Nishida from the CAB in collaboration with Carpentries and Turing Way. So you'll see more about that through the Bioconductor social media communication platforms in the next year. And again, encourage anybody who wants to get involved with that to join us. We have a multilingual working group. And as of today, we've got the annual call for new CAB members open. So anyone at any level, a user or a developer, is welcome to join, fill out the form. QR code is here. It's been shared in the main Bioconductor Slack, and I'll also post the links to these forms in the conference Slack as well. Okay, so that was the slides. Now, we are here to answer any questions you have. If you want to know how to get more involved or what we do, please feel free to ask. I'll stop presenting to show the other. Okay.
This one question, Alex. I still want to take it.
Thank you. So you mentioned earlier that they're getting more and more package submitted to Bioconductor, which does show that the community as a whole is actively contributing, but we have fewer package reviewers in general. Is there any other areas that both the CAB and the CAB have noticed are areas that you end up having to spend a lot more time in as individuals, where us as a community can also step forward and help over time?
So we've already gotten into the idea of reviewing packages that I think can be an extremely important contribution. The support site is something where, if you are reviewing it and, you have some insights to add, I think there are many items there that don't get answers in a timely way. So getting familiar with the support site, I think, is a very good way to get into the project. I don't know, other thoughts of where, I know everybody feels that they're overworked, and in a certain sense, we are isolating ourselves perhaps too much from effort that could be contributed from the community. Anyone thinking along those lines and where they could get some help?
Can you hear me?
Yeah, go ahead, Lori.
I know we get a lot of feature requests on our GitHub and GitHub issues. And while feature requests are nice, if you have the knowledge and background to make it into an actual pull request, a pull request is a lot easier to review and work off of than just putting in a feature request. So I would say that would be one thing too, that we do really like pull requests. And obviously, if you're doing a pull request and it's substantial enough, add your name as a contributor to the description so that you get credit for it too.
Okay, yeah, I have a question. So why people join these boards? I imagine it's like a lot of work. So how do you combine it with your like other job responsibilities? So can you comment on this?
Maybe I can comment as I recently joined the technical advisory board like a year ago, and I basically had the trajectory as many here in the audience. I started as a bioconductor user, then during my PhD and postdoc, I submitted a couple of packages to Bioconductor as a developer, and I got more and more involved. And at the end of the day, I knew a little bit of Bioconductor and thought I give a little bit back and contribute. And I think like the good thing is if you join some of these boards, you can kind of like make an influence, right? So you can kind of like drive a little bit also the research questions that you were interested in. So for example, I'm very interested in single cell, but also spatial, and recently these LLMs, and these are things where we desperately, I think, like and urgently need new developments, and bringing this to the boards and bringing this to the core is important. So that was one motivation for me to join.
I see Kozo Nishida there online, who I mentioned is one of the CAB members and has been leading the multilingual translation for a while. And I know he deeply cares about trying to make documentation and training material more accessible to people. So he's very passionate about that. So I guess that might be his reason for joining. Kozo, feel free to chime in. And I see Kevin and Charlotte, they're also volunteers on the boards. If you want to say anything, please feel free to unmute.
Maria, do you mean why I joined CAB? Do you asking?
Yes,
Do you ask?
exactly. Why do you join CAB when it's work, extra work?
Yeah. Because I like the open source community, the open source software for science. So I would like to help the community. Just it's my reason to join CAB.
Thank you. So, sorry, did somebody else want to speak up as how the reason why they joined?
Maybe I can just add a small point. I think it's, in addition to like contributing, it's also really useful to kind of learn what's going on behind the scenes, right? You just see the, you see some things when you're a user, maybe a contributor, but you actually gain a lot of understanding of how the project works by being on one of the boards.
And we have a question from a person in the online audience. What skills are expected of individuals joining the CAB, and what skills can they develop through their membership?
For CAB, for TAB, I would say you would need to be a developer, because you're discussing the technical aspects of the project. Whereas CAB, you could be a user, because we want to know how to support Bioconductor users as well as developers around the world. So I would say you need to have used Bioconductor package would be a minimal level of skill. And what skills can you gain? I think it depends on which working group you're involved with. If you're involved with teaching and education, you can learn more teaching skills, multilingual. If you want to get involved with COSO's project, you can learn how this translation framework works that uses a hybrid approach with AI as well as human curation. So there's a whole range. There's organizational skills if you get involved with the conference planning committee, and we will have a call for people to help with the next year's conference. BioC Asia is organizing their conference right now. I'm sure they'd love extra people. So event planning is always a good skill.
We don't expect members to be involved in like all of the working groups. Like we hope that you would take an interest that's important to you or that you would want to work on and join that particular group so that you have, you know, a passion and a liking for it as well.
Okay. Yeah. Hi. So there's one thing that remains not particularly clear to me in terms of involvement in TAB, and how do you get? Are you also expected to be part of a working group when you're part of the TAB, and also how do you differentiate the? So I went through. I've had the occasion to go through the minutes from the TAB meetings, and how does that translate into actions? And is it entirely decorrelated from the working groups themselves? I don't know if it's clear.
That's a question about the TAB, a very deep one and a good one. The TAB goes back a long way as a just sort of a loose discussion on a regular basis among developers who contributed to the project. I would be interested in your reading of the minutes, because they are often sprawling and do not lead to concrete technical steps. It's sort of taking the pulse, seeing whether there's some place where we really need to do something and letting people know when changes are happening. I think Hervé is often involved in refactoring or coming up with new paradigms for certain aspects of the project. So it's pretty loose. And I think that's one of the reasons it kind of works, because we don't make hard demands of people who are faculty members with funding problems of their own, et cetera. But we could probably do more to ensure that there are milestones that are met. The idea of direction of the project is itself quite amorphous. We have a lot that's going on for almost 20 years now. And when you have a project that's on everybody's desktop, it becomes difficult to change methods. So you learn a lot about what open source is and is not by participating at that level. Lambda had a question, I think?
Yes, it's relevant to both the TAB and the CAB. So I have the Museum of Spatial Transcriptomics, and I try to make it comprehensive. But one thing I have noticed from my database is that the vast majority of time, actually, it's not just in R, but actually also in Python, the vast majority of packages are not on CRAN, Bioconductor, or PyPy, or Conda. Like even though like PyPy doesn't even have those like manual check or like the R-command check kind of thing. So, but meanwhile, I do really appreciate the review process and the requirements of the Bioconductor projects. Like you have to have documentation, you have to have unit tests and so on. I think those are very important, and I always thank my past self for writing unit tests and documentation. So I really want to encourage more people to make their package fulfill those requirements. So how do you think? How would you encourage more developers to say like get our packages to Bioconductor, or at least CRAN?
Yeah, I don't think we have a good answer to that. We, as you know, don't allow Bioconductor packages to depend on GitHub only packages. And I think that's something that doesn't, it isn't a popular feature of the project. A lot of people want to use a piece of software that they think works, and we don't allow that. We're being moved into other domains now. I think Python is something where we're going to have to interoperate with in many ways. But how about PyPy? I mean, does it have sufficient control over version availability so that, we haven't really stated a policy about that. So if you're going to use Basilisk, which we do recommend, but we don't require, if you're going to rely on Python, how do you know that the Python versions of the packages that you're going to use through Basilisk are going to exist? Because some of them do go away. I don't have an answer to that. And having deeper discussion of that in the community, I think, would be welcome. Encouraging people to come into Bioconductor is a double-edged sword. We do want more packages, but the more that come in, the more work the group has to do, the more the ecosystem has to churn in order to do all the testing and so forth. So we welcome it. I think we do, want ideas about how to evangelize, in a certain sense, the values that come from the timed release, the control over changes in the release process, and the deprecation process of changing APIs. Those things came very naturally to us. I think they are the reason that the project endured for 2 decades, and more people need to adopt them. How to do that at the right level of education, research level that people have gotten to, I don't have good answers to that, but I agree that we need to do more.
Can I add a little bit to that?
Yeah, please.
Lambda, I understand that the question is how can we encourage more people to submit their package to CRAN and Bioconductor, right? And I think my main reason was to put a quality tag on my packages, right? A tag of high quality. I see that a lot of people these days say, okay, it's maybe enough to put it out on GitHub. That is easy enough, but there are no guarantees around that, right? Everybody can remove their packages from one day to another from GitHub, right? These kind of things are not possible if you put this on CRAN or Bioconductor. So there is a little bit of notion of sustainability there, right? And if you put it up on CRAN, you ensure that this package has undergone some automated checks, right? So this package actually passes our CMD check. So you give the user a guarantee that you can install that package. And then Bioconductor, which I think are kind of like the top tier packages, there you give additional guarantees of what kind of like documentation you provide, right? You guarantee a vignette where you demonstrate how your functions play nicely together. So I think like the encouragement for people should be, I want to put out the best R packages possible, and that will be a submission to Bioconductor.
Thanks for this opportunity to learn more about the CAB and TAB and core team. So as both a user and a contributor to the Bioconductor, I'm really interested about the future of Bioconductor. So is there a place that as a user or a community member, we can collectively understand where the community could go? Is there a strategic development plan? And also if there's available to the community members that we can start understanding the direction to go. And also as well as if that documentation is not public yet, I'm just curious, is there a certain vision on how Bioconductor community would go in 3 years, let's say, or 5 years, depends on how you want to put a time mark on it. And is there specific milestones that the team, the whole core team, all the team trying to navigate towards to? Thank you.
I'm willing to, I appreciate that question. I think it's great. I think the idea of strategic planning has been floated by various people connected with the project and in the TAB. I do not think a strategic plan exists. There was a grant written about 4 years ago, or funded around 4 years ago, that has a set of timetables, milestones, let's say. And you'd be surprised just how many things changed to intervene in the accomplishment of many of those goals. For example, introducing the M1 Mac as a widely used platform, that wasn't part of the grant. We didn't know about it then. So, the adaptability of the project through its looseness, I think, is fundamental to its sustainability through the energies of the people in the core and the community. But it's also a bit of a liability in the sense that people are uncertain. They don't know what's going to happen. What's your strategy? How can we move it in a direction that is better for us? And I think the openness of the project to input of these types has always been the case. And so we would welcome your input. It can be something filed on the support side. It can be an email to us, a blog post. So I think you've made a very good point, and I would welcome input from those who are interested in strategic planning on how to introduce something like that to the benefit of both the core, who are very over committed, and to the community. Another question? Yeah.
Another big picture question. I'm just wondering if either of the boards have an idea of how they define the bio and bioconductor. It seems like it's mostly focused on molecular data. Just wondering, I may be wrong in that assumption, but if there's any kind of vision of expanding it more into, say, ecological data analysis or phylogenetics or things like that.
Well, I think actually Vince is better suited to answer that question, but I think from history, the project had a focus on genomic high throughput data. This is where the bio came from, right? So Bioconductor got founded in the days of the microarrays, right? So high throughput gene expression data. This was what Bioconductor was all about. And then, omics world, multi-omics world started to exist. So people also started to look maybe at proteomics data and more genomics data, right? And now these days you have microbiome data as well. So that's why the bio actually becomes more than just genomic data. I don't know whether there's a plan to go much beyond omics data.
Well, right, omics. I would just recommend that you take a look at the experiment hub and the annotation hub for a sense of breadth of data resources that go beyond, let's say, human genomics. We've always been pretty light on human genetics, but model organisms, I think there's lots of resources out there for that. As far as other domains, like you mentioned, ecology, epidemiology, and so forth, I would say we're open to that in the sense that if an R package that meets the conditions of Bioconductor's quality barriers, I think we would move in that direction. For example, Robert Gentleman has been talking about something called Epiconductor, which would be useful for epidemiologists, would package NHANES and other large-scale epidemiological resources. I don't know whether it become part of Bioconductor or just follow Bioconductor principles, but those things are certainly welcome and are sort of on the horizon.
I was just wondering, so as the number of Bioconductor packages is expanding, what is done during the package, when you submit a package, to check on redundancy with other packages and to check that we're not just expanding and creating more functions that do the same things? Because as someone that's like a start-off user, you go to do a particular test and you find actually everyone does it differently using a different Bioconductor function. So how do you work that into the submission process?
I would say this is an FAQ. I think I was at a European Bioconductor conference in 2014. This is 10 years ago, and I asked exactly that question. And I think Wolfgang Huber back then answered me, which resonated a lot to me, is we might not necessarily need to be so strict on redundancy because the best package will win in the long run. Right, so we might allow different packages that kind of solve the same purpose, and the user will decide who is actually the package who will get used and be the popular one, whereas the other package will likely more and more vanish.
I can add a little bit to that. During the review process, it's very important for the reviewer to know several aspects of the project and suggest where what I do in my reviews. I tell the maintainer, have you seen this function does it do something similar to what you're trying to do? And if you're enhancing it, maybe contribute to the code base. So
Yeah, we've started asking for, as part of the vignette and an intro abstract session, to have a comparison to existing bioconductor packages to explain why it's different or what is novel about that package and its function. So we have started asking for that requirement in the vignette as well.
Another comment? Okay, I'll just make one additional remark on this. The annotation of packages is currently carried out using something called BioC views, which is an ad hoc vocabulary that categorizes all of the resources, and it's actually a fundamental part of the build system. We're working with the folks at the Pasteur Institute on an ontology called EDM, which is an attempt to become much more fine-grained and sort of machine-oriented in terms of the classification of software tools. So it should be easier to find those things which might overlap with something that you might be working on. End of that comment. Next.
It was just a follow-up question. So, okay, the package is out there, and from a technical point of view, it passed all the checks, it works, everything's fine. How do we make sure that it's, let's say, biologically relevant, that you can draw like biological findings out of this package? I mean, otherwise, what's the point of having this package? I mean, is it just for the sake of having a package, or can I apply it somewhere?
Any thoughts?
Just it has been suggested that we do more technical, biologically relevant reviews and have people in the field to review packages. The problem is that, again, it's always volunteer, and right now we're limited to even do a technical review of the package. So in an ideal world, we would have enough volunteers from the community that we would ideally love to assign 2 reviewers, one that would do a scientifically relevant review and one that would do a technical. We just don't have the scope for it at this point in time. And again, I think that goes back to what Luguit said of, you know, the better packages, the well-explained, the ones that are working, that are relevant, will rise to the top and be used and consistently used and cited.
Yeah, I would say that's a place where if you feel like contributing to the project, you have some time, we'd be happy to have your input on relevance to whatever field you are most concerned about.
Hi, so I just started working with Bioconductor like 2 months ago, so I might be saying something very dumb, so bear with me. But some struggle that I've had is that the documentation is wonderful, and every time I ask my supervisor to look at the code, he's like, oh, did you read this or check this part? And that works wonderful. But something that, at least from my perspectives, I couldn't find, it would be like automatic linting, because it seems that a lot of the standards of Bioconductor are very clear. But even from today's, for example, package development workshop, they uses the standard package from R. But Bioconductor has its own very specific things that need to be addressed, right? Things from like camel casing or from the imports on the Roxygen. And it seems that there's quite a bit of overhead on the reviews of these packages, which could maybe address through some automatic linting. And I wonder if this is something that there's something available already, or is something that should we think about, or yeah.
If I heard you correctly, it was linting?
Well, among other things, just, you know, like the
yes,
basic.
I would say automating aspects of the review process and giving more automatic feedback to a developer is definitely on the radar screen, but not there yet.
What do you exactly mean with linting?
I mean, so, for example, a very basic thing is the standard for Bioconductor is camel casing for variables, right? And functions should be adverbs or something like that. So in the lint, there's styling packages.
Styling.
Or,
okay.
I mean,
So
But
I think
it's
there.
the whole entire
Gotcha.
thing.
So I think there are two things that are coming to my mind. The one thing is there's something like BioC check, which I think Marcel and Hervé can talk more to. So basically, in addition to the standard RCMD check, it kind of like applies some automatic checks for adherence to bioconductor guidelines. And then with styling, you might be aware of that styler package, and that I think has, I saw someone from my group using that. You can also say use BioC style. I don't know the exact syntax, but it's available to kind of like apply to your package, and it styles your code according to some bioconductor template.
Yeah, so that's what I thought, that the styler does the tidyverse styling, but I couldn't find the bioconductor styling.
There is one.
Okay,
there
so then I
is
just need to
one.
find
I'm
it.
going to paste that command in the BioC Slack.
Perfect. Thank you.
Does someone want to say something about BioC check or?
Oh, not about BioC check, but I'll add that we're also trying to work on a GitHub action. There is already one BioCDS, but working one that's more universally checking for everything, and I think linting would be part of that, to first tell you about things that we can just infer from the syntax of the code, then actually try to do a mimic of the build similar to what the SBB or the BBS would do, and give you a result to that. And I think that would improve the developer experience a lot, and that is on our radar.
Hi, thanks for the previous answer. I guess I have two questions. One is about the future again, and then one is about the past. So the future question is, so is there any specific, like the financial perspective, you mentioned there's cuts from specific founders, and then is there anything that the community, or is there a community strategy or milestone or ways that can be more financially sustainable for the development of bioconductor? And then is there anything that members can do, such as writing letters to their congressman or something to ask for funding to this specific project? But also, I think another question I have, which is about the past, is that you mentioned there's other group people trying to relic the heroic efforts of bioconductor throughout the year. Is there a way, such as you mentioned API conductor, or there's a group of people are building the neuroconductor? So is there a place that people are starting these efforts could learn from the history of the bioconductor to borrow some inspiration from that to build a better ecosystem for their own benefit? So is there a documentation, I know this is much to ask, documentation about the history, or is there a better way to build connection between these other communities to learn from the experience, the valuable experience that bioconductor community have? Thank you.
Right. So I don't have a good answer on financial sustainability. I would like to have a better one. Maybe we'll come up with one in the near future. We really need to. Being part of NumFocus, if you haven't heard of that, it's an important fiscal sponsor of a number of global open source projects, some of them quite small, that we've become attached to recently. And they have many interesting facilities for working with open source projects, and probably getting acquainted with that would be good. Chan Zuckerberg Initiative's EOSS has also been helpful to us, and I think getting an understanding of that ecosystem and that funding model. Also, the Sloan Foundation has interesting open source initiatives. So, we're going to try to explore those to reduce the vulnerability of the project to changes in federal funding. Also, mobilizing NumFocus to allow more donations, both at the user level or at the consortium level for industry. That's something we're trying to move forward on. The question about the past is a good one, and I can refer you to a 2005 paper. I think it was in Genome Biology. It was the first paper about bioconductor. And there, it explained some of the issues about looking at BioPerl, BioJava, other things that were going on at the time. And you might wonder, how sustainable were they? How did they maintain their impact, what it was? And I think, again, highly voluntary, under-managed approach that has occurred in Bioconductor is, in a certain sense, an important component of how it survived. If you look at the R core and the R project and CRAN, I think you'll see that there's a lot of freedom for people to be creative and follow what they think is interesting and not be constrained by, hard deadlines and specific deliverables. I think that's been important to keeping people engaged. And as long as the general momentum is there, it survives and it's doing well, but it also needs analysis from other avenues. There's something called chaos, another important thing to think about. It means community health of open source software. It's sort of a sociological organization that develops metrics on open source projects like Bioconductor, and some of the metrics, it's CHAOSS. Some of the metrics involve responsiveness to user inputs. So for example, if you have a lot of repos and a lot of open issues that have not been resolved, that's a sign of less health. If things are being resolved and answered rapidly, those metrics are advantageous for the project. We don't do a lot of formal metrics on responsiveness, but they do. And that may be worth looking at for thinking about how you could do your own project in a similarly impactful way. I'll shut up for a while. Other comments in this domain?
I can maybe think out a little bit out loud. So what made Bioconductor successful in the first place, right? I think Vince mentioned that Bioconductor 2005 paper, right? And back then, I think I was an undergrad, and what turned me to Bioconductor were just like these high standards of reproducibility, transparency, and just the most sound statistical models, right? So all these normalization methods for microarrays, all these differential expression methods, that were best in class, and they were available in Bioconductor. And if you go to bulk RNA-seq, DSeq2, Edge, or Lemma, right, these were best in class. So people were turning to Bioconductor. That's the main reason why people turn to Bioconductor. And I think if we want people to continue to turn to Bioconductor, we need to continue to provide best-in-class software, best-in-class packages for interacting with large language models, with spatial data. We saw Lambdas talk with interacting with Python. What I have difficulties to pronounce your name, but you from Genentech did. I think that is super important, and there the community can help. And if we put out best-in-class packages, also the funders will come and give money to continue to do that.
One more comment that I think would be worth looking at. There's a nice blog by a faculty member at Columbia called Causal Inference and Statistics, and it recently had an entry. The person is Andrew Gelman, a famous Bayesian statistician. Had an entry on a paper written by David Donahoe called Frictionless Reproducibility, or something like that. His thesis is that this explosion of success in machine learning and AI is due to factors that he says contribute to and must be present for frictionless reproducibility. The code must be open. What's another one? The code must be open. The data must be open, right? So what we're going to work on, what we think is a good resource to analyze, must be open. And third, there has to be competition. There have to be leaderboards, ways of measuring relative effectiveness of different solutions. And if any one of those is missing, then the domain does not receive the same level of progress as those that satisfy all three conditions of frictionless reproducibility. I think the idea of a vignette in a bioconductor package was absolutely fundamental to its early success. It guaranteed articulation of the meaning of the package. It guaranteed computability of all of the different things that contribute to its meaning, and it was something that anybody could write and anybody could compile. And that's work due to Fritz Leisch, who passed away recently, unfortunately, who was a member of our Corps, with his S-Weave system, which goes back to Donald Knuth's literate programming paradigm. So this idea of executable documentation that becomes both a way of teaching people about how to use the thing, but also doing quality assurance of the software at the same time, I think those are really important. And they're missing in certain ecosystems. So I'm just trying to point out little things that we take for granted in Bioconductor are absolutely absent from other components of scientific computing infrastructure, and we insist on them and can't go back. Learning about new things like Corto, which can bring more interactivity and so forth to these documents, I think will only make this better. But it's, again, more work for developers and for us to process these and make them available in the same way that we make ordinary vignettes available. So we welcome contributions to make all of that work together.
I was going to say, I think we might be over time, but we could continue discussing on the walking tour. Is that right? Erica, do we need to make any, we're going to be meeting at 6 o'clock at the Calder Plaza, whoever wants to go on the tour. So big red sculpture that's in the sticker. It's about a 6-7 minute walk from here, but you can go back, drop off your bag at your hotel if you're nearby and don't have to bring it with you. And the map for the walk has been posted in Slack. Is that right, Tim, in the local tip?
I think so. We could throw up the QR code if people need it.
Throw it in again. And if you get lost, can't find us, ping us on Slack, on the conference Slack.
And I'm committed to, if people are not going back to their hotel or don't have a bag to check in and just want to walk down from here, I'm happy to stick around until 5:45 and walk down with anybody who would feel more comfortable that way. So.
Okay, and thanks to the virtual members who joined us online as well from Core, Cab and Tab. Thanks everyone for this great session.